Okay, we've got the section 5.3 about the inverse cosine function. And your basic cosine function, as we know, starts out at its maximum and repeats after a cycle of 2 pi. It has a domain of all real numbers and a range of -1 to 1. The question is the inverse a function? And the answer is definitely no, the inverse is not a function. And one of the reasons we could say is because it fails the horizontal line test. You draw a horizontal line through this graph and it will cut it more than once. Okay? In fact, it cuts it an infinite number of times. So, and if you wanted to see a picture of it, there's a picture of the actual inverse function as it continues to go on forever and ever, up and down. So if you did show it, which is a reflection across the line y equals x from the original, you would see that it fails the vertical line test. So that's another way that you can look at that. So what we need to do is we need to restrict the domain. That means we need to throw away most of it, but keep the range. So we want the range to stay the same, but we want the domain to be restricted. So three things have to be true. And anytime you want to pause this during the video to write things down, feel free to do that. Three things have to be true. One, we must keep the angle measurements between 0 and pi over 2, since these are angles in a right triangle. Second thing, we definitely want to keep the range from -1 to 1. The last thing that we need to do is it must be a continuous interval. So if we choose from 0 to pi over 2 and we have to keep the range -1 to 1 and it has to be continuous, the most logical, the only choice we have is 0 to pi for our new domain. What does that look like, MrJStailey? I am so glad you asked me. Okay, so this is the inverse cosine function. After we chopped up the domain of the cosine function and only used 0 to pi, that would mean the range of the inverse cosine function would be 0 to pi. And its domain is -1 to 1, right? If you're taking the inverse function from the cosine, the domain and ranges would switch, okay? You're going to see some notation in the book. Cosine inverse of x is the same thing as arc cosine of x. Do not ask me why in the world we have two different notations. They are the same thing. Probably, arguing math teachers or something ridiculous like that. Example 1, the exact value of cosine inverse of radical 2 over 2. Okay, your answer can only be between 0 and pi. If you're thinking about the circle, that would be the top half of the circle. So the answer has to be between here and here. Radical 2 over 2, that's an x value which is sitting right here. And if I follow it up to the top half of the circle, I hit that point on the circle, and since we all remember our unit circle very well, that's right, you cannot forget your unit circle ever. We would find out that the pi over 4 would be the value that we would need for that. Pi over 4. If you asked me for, in other words, we're giving you an x value and asking you for the angle measurement between 0 and pi that goes with that. So for instance, -1/2 is your x value, and you come up here on the top half of the circle, that would be the angle measurement 2 pi over 3. 2 pi over 3. So pi over 4 would be here, 2 pi over 3 would be there. Example 2 that they show you in the book is the cosine inverse of this whacked out decimal, -0.7924. The only way you're going to do that is with a calculator. Make sure your calculator is in the correct mode. In this case, they asked for degrees, so you would make sure it was in degree mode, and then invert the cosine on your calculator to get 142.4 degrees. It's the only reason you need to use that. Well, continuing on here. No calculator for these things. Cosine inverse 1/2. 1/2 sits here. The x value, if I go straight up, I hit pi over 3. Cosine inverse negative radical 3 over 2. Well, negative radical 3 over 2 is way over here on the edge of the circle. Following it up, I hit 5 pi over 6. Cosine inverse radical 2 over 2, same question we asked just a few minutes ago. It's going to be that pi over 4. I wish your math teacher used a better example than the copy one down that he had before. Guess what? These questions right here solve cosine theta equals 0.5, cosine theta equals negative radical 302, and cosine theta equals radical 2 over 2. These questions look different than the ones that were up here at the top of the screen, but they are not different. They are exactly the same. Exactly. Because what are you going to do? You're going to invert the cosine. You're going to invert the cosine all the way through for all of them. Okay, next topic we're going to talk about is the composition of functions. The composition of cosines. Well, if you got a cosine and a cosine inverse of 1/2, well, the cosine inverse of 1/2 we just figured out a few minutes ago was pi over 3. What's the cosine of pi over 3? That's the x value for pi over 3, 1/2. Oh, look, the same thing you started with. When the trig function is on the outside and the inverse trig function is on the inside, they always cancel out. Always, without fail. That's true for sine, cosine, tangent. So when you look at this, cosine of cosine inverse of radical 3 over 2, boom, radical 3 over 2 is the answer. Don't even have to think about it. But not so easy when you reverse these things, okay? So if I put cosine inverse on the outside and cosine of pi over 3 on the inside, well, the cosine of pi over 3 is 1/2, and the cosine inverse, that's an angle measurement on the top half of the circle between 0 and pi that has an x value of 1/2. Well, that's pi over 3. Oh, wait a sec. I thought you said they wouldn't cancel out always. Sure looks like they canceled out to me. You started with pi over 3 and you ended up with pi over 3. Well, take a look at it again. You started with an angle measurement that was already in the range 0 to pi. Therefore, you're going to give me an answer between 0 and pi. So, of course, you're going to stay in the top half of the circle. And, of course, it looks like they cancel out. The problem comes in when we start going outside of that. All right, for instance, cosine inverse of cosine of 5 pi over 4. Well, 5 pi over 4 sits down here. If you follow the logic and you go cosine inverse of, well, what's the cosine of 5 pi over 4? That's negative radical 2 over 2. And what is the cosine inverse of negative radical 2 over 2? 3 pi over 4. In other words, it sends you straight up to the top half of the circle. Your answer has to be between 0 and pi. Look at a different example. Cosine inverse of cosine of negative 2 pi over 3. Well, what's the x value for negative 2 pi over 3? If you look back up here at the circle, here's negative 2 pi over 3. The x value is negative 1/2. So, we got the negative 1/2 part. What's the cosine inverse of that? That means, what's the angle measurement between 0 and pi on the top half of the circle? Well, it has to be 2 pi over 3. In other words, it sent you straight up to the top half of the circle. 2 pi over 3. When you get good at this, I want you to skip the middle step. Don't even worry about this middle step. You go straight from here to here because you know that you're following along x values to the top half of the circle. That's the best way to do it. 11 pi over 6. What about happens at 11 pi over 6? Well, if you look back at your circle, here's 11 pi over 6. If you go straight up from there, you get to 1 pi over 6. So that's your answer to that question. In other words, the moral of the story for cosine inverse x, it sends you to the top half of the circle between 0 and pi. Okay, we're going to do the same thing with the inverse sine function. So we're going to be restricting the domain of the sine function for the exact same reason we did it before with the cosine. You've got this sine function that's got a domain of all reals and a range from -1 to 1. The inverse is obviously not a function because it fails the horizontal line test, just as we talked about earlier. So if we have to go through the process of restricting the domain, we're going to go through the same criteria that we did before. It has to have all the angle measurements for a right triangle. It has to contain the range -1 to 1, and it has to be um, a continuous range of values. So if we do that, we end up with -pi/2 to pi/2 closing on the endpoints. In other words, we're going to contain the endpoints. This is the restricted shape of the sine function that we have chosen, with -pi/2 to pi/2, but exactly the same range. When you reflect across the line y = x, you get this looking shape with this domain and this range. Notice how the domains and ranges have switched. Now, where does that put me in relationship to the circle? It puts me on the right half of the circle, over here, folks, from -pi/2 to +pi/2. And that's not the top half, but the right half. Yes, the notation you see in the book, sine inverse and arc sine, are the exact same thing. We're going to ask you questions like, what's the sine inverse of radical 2/2? Well, radical 2/2 sits here. If I need to go to the right half of the circle, that's pi/4. Remember, the answers can only be between -pi/2 and pi/2. Sine inverse of -1/2. Well, here's -1/2. If you follow it over, you get to -pi/6. If you look at some of these other ones, you see +1/2 goes to +pi/6. Negative radical 3/2. You can't call it 5pi/3, which is what many people want to call this, because your answer has to be between -pi/2 and pi/2. This is where it gets tricky with the wave and the circle. 5pi/3 is the same place on the circle, but it's not the right angle because it's not in the range of the inverse sine function. Remember, you can only choose between -pi/2 and +pi/2. So we have to call that -pi/3. Sine inverse of -1, ooh, that's at the bottom of the circle. That would be -pi/2. Don't call it 3pi/2. Right place on the circle, wrong angle measurement. Compositions again. Compositions like sine of sine inverse of 1/2. Oh yeah, that's the one where if you have the trig function on the outside and the inverse trig function on the inside, they cancel out. So whatever you started with is exactly what you end up with. So keep that in mind. Now, it is true that if you switch that around and you have sine inverse of sine of, oh, there's an angle measurement between -pi/2 and pi/2, so you started with something that was in the correct range. Therefore, it will look like it cancels out, and you will always end up with the same thing you started with. But you know that there's a lot of other examples that that's not going to happen for. For instance, let's get this situated. If you start with 2pi/3, that's going to send you to the right half of the circle, pi/3. If you start at 5pi/4, that's going to send you to the right half of the circle. Please don't call it 7pi/4. Please call it -pi/4. Right place on the circle, wrong angle. 5pi/6, sending me straight across the circle, 1pi/6. 5pi/3, that's 5pi/3 right there. Well, that's on the right half of the circle, so it's going to bounce and come right back. But don't you call it 5pi/3 because the inverse sine never spits out an answer that's greater than pi/2. So it's got to be between -pi/2 and +pi/2. So even though it's bouncing off the axis and coming right back, you still have to label it correctly. So that's what these notes say. We started on the right half of the circle, but it doesn't cancel because it's not inside the range of the function. So 5pi/3 bounced off the y-axis and stayed on the right half.